The end behavior of a graph is the behavior of the graph as x approaches positive infinity or negative infinity. Sometimes it is required to describe the end behavior as x approaches an integer. The notation you will use for end behavior is as x approaches something, f of x or y approaches something. Let's look at example 1. This is a square root function. Notice as our x gets larger and larger, so if we move along the x-axis and they are getting larger and larger, the f of x is also going to grow larger and larger. Here along our f of x axis, it grows larger and larger as the x grows larger and larger. So our end behavior is going to be as x grows to infinity, as it gets larger and larger, f of x is also going to grow to positive infinity. An infinity symbol is like an 8 laid on its side. Let's also talk about as x gets smaller. Here it's not going all the way out to negative infinity. It stops. As x gets closer and closer, it's stopping at 0. So we'll say as x goes to 0, it grows smaller and reaches 4 for the f of x. So look at your y-axis. As x grows smaller and smaller, it's going to get to 0. So as x goes to 0, our y numbers go towards 4. So that is the end behavior of example number 1. Let's look at example number 2. This is a cube root function. So notice with this graph, as our x's get larger and larger, so as we grow larger and larger in our x, the g of x, or the y values, are going to get smaller. So we're moving along the positive infinity of our x's, but our y's are getting smaller and smaller. They're getting more and more negative, so they're going to negative infinity. So we'll write that as x grows larger as it goes to infinity. F of x will go to negative infinity. Because it is getting smaller, it goes towards the negative infinity. Let's also look at x getting smaller. As x gets smaller and smaller, so as we move along the x-axis, smaller and smaller, as it goes to negative infinity, this time the f of x are growing. Those values are getting larger and larger on the f of x, or the y-axis. This function is actually called g, so we need to name that also in our end behavior. So as our x is getting smaller, our y, or our g of x, that function, is growing. So we'll write g of x goes to infinity. Let's look at example 3. This is a quadratic function. Look at your x values as they grow larger and larger and larger. Notice your y values first start to decrease, but really we want to go over the whole end behavior. So we really only care about where is it ending up. So even though, yes, it decreases for a minute, it's going to come right back up. What does that end behavior do? So as x grows larger and larger, as it goes towards infinity, h of x is also getting larger. So we grow out larger and larger on our x-axis. Our y numbers are also growing very large. So our h of x also is going to infinity. Let's look at the other direction. So as x is getting smaller, as it goes to negative infinity. So here, as we get smaller and smaller on our x values, out towards negative infinity, our y values are still growing. They're still getting larger and larger to make that U shape like a quadratic does. So our h of x, as our x's are getting smaller, as they're growing towards negative infinity down this way, our y values are growing large. So it would go to positive infinity. Let's look at the last example. If you would like, hit pause to try it on your own and then press play to check your answer. For the x values, as it grows larger and larger, so as x goes to infinity, notice what's happening to f of x. As our x goes out to infinity, it only shows a small portion of that on our graph, but we can still notice as x is getting bigger, our graph very quickly went in the negative direction, so it's very quickly going to grow to negative infinity. So as x increases, as it gets larger and larger, our f of x is going to get smaller and smaller out to negative infinity. In the other direction, as x goes to negative infinity, as we grow smaller and smaller on our x-axis and go out to negative infinity, it never will actually reach out to infinity here for the y values. Notice how it starts kind of flattening out for an exponential function. It never will quite reach the 3. It will get very, very close. So we'll say as x goes to negative infinity, as it gets smaller and smaller, it gets really, really close to that c value, or 3. So we'll say f of x goes towards 3.